Hey, geometry students, welcome back to another lesson with Mr. Chaz. Today we're going to be proving segment relationships. If you've noticed, we are working our way through what we call the proofs section of geometry. We are proving everything that we come across now, and today we're going to be proving segment relationships. The good news is we're no longer going to be doing paragraph proofs. We're going to be doing what we call two-column proofs, where you're going to just write a statement and then you're going to give the explanation or the reason. So I'm going to go right into it. The ruler postulate. Two basic postulates for working with segments and links are the ruler postulate, which establishes number lines, and the segment addition postulate, which describes what it means for one point to be between two other points. So the ruler postulate is this: the points on any line or line segment can be put into one-to-one correspondence with real numbers. So when you look at a ruler or a number line, so the ruler starts with 0, but then it goes to 1 inch, and then we got 2 inch, 3 inch, and so forth. That's the ruler postulate. So if we had a ruler, that's what it would be, right? Segment addition postulate says if A, B, and C are collinear, meaning they are in the same line, then point B is between A and C if and only if AB plus BC equals AC. So if I had a line segment A, B, and C, so that's a line segment AC. Well, we know that AB plus BC would equal AC. The whole thing, AC. So that's all that's saying. So, example, write a two-column proof. Given Q is the midpoint of PR and R is the midpoint of QS, prove that PR equals QS. So we always start out with the given. Q is the midpoint of PR. The reason? Well, it's in our given. They give us this information. And since they give us this information, we don't have to think anymore. We just write it down. Given Q is the midpoint of PR. Well, the definition of midpoint, so it's saying that Q is the midpoint of PR. Well, the definition of a midpoint is that PQ would equal QR. So we can say PQ equals QR, the distance of each, because of the definition of midpoint. That's what we're using, the definition of a midpoint. I'm going to change the color here. Now we're going to write R is the midpoint of QS. R is the midpoint of QS. How do we know? Well, that is given. Given. So that's our reason. We put given. Now, R is the midpoint of QS. So that means that this is equal to this. QR is equal to RS. How do we know that? Well, because that is the definition of a midpoint. It's the same thing that we have. That would mean that QR equals RS. That's the definition of a midpoint. Now we're going to be given PQ equals RS. PQ equals RS. And the reason we're given that is because of transitive property. Alright, if PQ equals QR and QR equals RS, then that means PQ, and I'll put this in a different color, so I'll say that again. PQ equals QR and QR equals QS, that would mean PQ has to equal RS. So PQ equals RS, and we call that the transitive property. So we're justifying, the reasons are justifying each of our answers as we go. So then we have PQ equals PQ plus QR has to equal QR plus RS. So PQ plus QR has to equal QR plus RS. Well, we know that PQ equals RS, So QR equals QR. So PQ plus QR has to equal QR plus RS. And that's called the addition property. So now we're at the point where PQ plus QR equals PR, right? PQ plus QR equals PR. Well, that's the segment addition postulate. And we have QR plus RS equals QS. QS, PR. That's the segment addition postulate. So now we can say that since PQ plus QR equals QR plus QS, we can say that this whole quantity here, PQ plus QR equals QR plus QS, since they're equal, that would mean that PR has to equal QS, and that's what we were trying to prove. We were trying to prove that, and we did. So PR equals QS by substitution. So I'm going to go ahead and do the next, I'm going to do the problems with you guys. It is your responsibility to plug in the answers, though. I'm going to give you the answers, but you are still responsible. If you want full credit for the assignment, if you want credit at all for the assignment, you need to put the answers in yourself. So we start off with complete each proof. So given BC equals DE. Notice our first statement is BC equals DE. Well, where did we get that from? We got that because it was given to us. So we're going to write in here, given. Given. So we're trying to prove AB plus DE equals AC. So they put that down there already because that's our final step. So if BC equals DE, first thing we need to know is that AB plus BC equals AC. So we're looking at this, and I'll change the color. We are looking at this segment here. So AB plus BC has to equal AC. So we get AB plus BC equals AC. And keep in mind, what we're trying to prove here is that AB plus DE equals AC. But we know that BC equals DE. So I can take that BC and say, instead of putting BC, I can change it to DE because they're equal. And so how do I do that? I say substitution. I'm just substituting. Takes a long time to write these down. Substitution. And I proved what they asked me to prove. So that's it. So what you guys have to write down is given AB plus BC equals AC and substitution. We're going to go into our next problem, which is a little bit longer of a proof. And we're going to work through it. So they give us a bunch of different things. Q is between P and R. R is between Q and S. PR equals QS. So first thing I want to do, on my drawing here, I want to say PR equals QS. So I want to see this. PR equals QS, just so you guys can see that. So they start off with Q is between P and R. Well, they already told us that. Q is between P and R. So that is given. So if Q is between P and R, that means that PQ plus QR has to equal PR. And that is segment, and we can abbreviate, segment addition postulate. All right, segment addition postulate. Next, they say R is between Q and S. Well, where did we get that from? Right here in the given. R is between Q and S. So we're going to write given. Given. So if R is between Q and S, and they want us to use segment addition postulate, so our statement is going to be QR, right? Because we're showing that R is between them. QR plus RS equals QS. So we use the segment addition postulate. Now they say PR equals QS. Well, where did we get that from? PR equals QS. That is right there again. So that is in the given. So when it's given, we don't prove it. We just say it's already told to us. So given. So we have PQ plus QR equals QR plus RS. Well, how do we know that? Because PR equals QS, and we already proved that PR is actually PQ plus QR, and we proved that QS is QR plus RS. So now we can say that PQ plus QR equals QR plus RS. And the reason we can do that is because of substitution. Substitution. So now if you notice, if this were just an equation, we're subtracting QR from both sides. Because QR is on both sides, we end up canceling them out when we subtract, right? So we'll be left off with PQ equals QR. So what are we doing here? We are using what we call, notice we're subtracting, so we call this the subtraction property. Subtraction property. So when we subtract them, if you notice, QR cancels here and QR cancels here. So we're left with PQ equals RS equals RS. And if you notice, what were we trying to prove? Here we go, PQ equals RS, and we proved it down here by using substitution. So that's it. When you're writing proofs, and we're going to be doing a little bit more of this for the rest of this chapter. So when you're writing it, you just have to justify all of your steps. Again, you are responsible to turn in on your work. You are responsible to fill in what we did. Watch the video, slow it down, pause it, try to understand what are we doing each step of the way. Figure it out. Do your best. All right, guys. Any questions, reach out. Thank you. Have a good one.